So good afternoon everyone. I'm myself Devangshu Kalita, and today I'm going to teach statistical mechanics. Statistical mechanics. Statistical. So if you are preparing for IIT or JEST exam, then I'll teach you regarding this type of two exam according to the syllabus of this exam. So there will be almost 30 to 40, almost 20-minute lecture, 20-minute video I will upload, and this will be enough if you are preparing for ITGM or just if you go with me and if you look at this video, if you study from this video, then you'll definitely qualify ITGM or just exam. So I will upload this video in within 1 2 month. So even in CSN net also, if you are preparing for CSN net also, then also it will be helpful to you if you can gone through with this video. So first, today will be the introduction part of what before going to the statistical mechanics main topic. So first you have to know what is the statistical mechanics actually, and what is the relations between thermodynamics and statistical mechanics, and what is the difference between them, and why should we use statistical mechanics. Even after we have thermodynamics also, why we should study this particular mechanics for understanding a system. So first we'll go to the thermodynamics part, little just like overview type. So in thermodynamics, I think everyone know about this because in class 11 12 also is there. So in the thermodynamics, we discuss about the system. This may be system of gas, system of any other solid also, liquid also. So here let's suppose we consider a gas in a volume V, and number of particles is there. So in thermodynamics, we get some relation, and the relation is in between some macroscopic term. I think you will not understand what is the macroscopic term. In tomorrow's video, I will explain what is the macroscopic term. So macroscopic term, basically I can just for today I can tell you like the term we can which can find outside study like we can measure from outside point of view, like otherwise we can measure from outside point of view outside point of view outside point of view whatever the macroscopic term actually, number of particle, volume, temperature, pressure, all is the macroscopic. This is a macroscopic term. Macroscopic term. So in thermodynamics we get some relations. In studying the macroscopic term, we try to connect some relation between them, and that's how we study about this system. Like this is a famous relation, PV equal to nRT. In thermodynamics, this type of relation we get using this thermodynamics, and I hope you get some idea about thermodynamics. Now I go to the statistical mechanics part. So, and what about the statistical mechanics? Same system. Let's consider the previous system again, which I discussed about the thermodynamics part. Same system, volume V, number of particles there. So in thermodynamics, we just discuss about macroscopic term like NV. We measure from outside point of view. That term we get some relation, but we can study this system again using this if we can consider to each particle, we can study each particle, we go very deep level of under thing, and we can study this system this way also, like there are a large number of particles present in the system, and if we go to the all this particle and their behavior, we can how they are in different energy they are filling up, how different orientation they have taken. So if you go into all this stuff and we can study this about this system, then this also a study, this also this way we can also study the system. And this study has been done in statistical mechanics. Statistical mechanics, this study. And why this statistical came here? Name came here. So if you do this type of study, so many particle, so there is lakhs numbers of particle, lakhs, crores number of particle is there. So if you want to study lakhs crores numbers of particle, that's it's very difficult. So that's much calculation. So statistics comes here. That's why statistics comes here. Statistics actually calculate all this time, all this thing, and do very easily take some average type of thing, and so you in statistical mechanics, so there is some term is common like average, doing average, most probable distribution, and probability. This type of thing is common in statistical mechanics. You will, when I'll go further, you'll heard about this all these things. So that's why statistics came here, and this is the actually real job in of statistics in this regarding the study of the system. So this is the overview of what is the statistical mechanics actually is. Statistics actually do we study all this system, we study all this about all this particle, and take some average term from there, and that's using the average term we get some relations between macrostate and microstate. And macrostate means I already told you the volume, temperature, pressure, this type of macrostate. And microstate is like there will be statistical term will arrive some there, and through connecting the macrostate and microstate, we get the relations between them, same relations that relations you already get in thermodynamics. So using this type of thing, we also get the same relation. But using this type of thing in statistics, it's very perfect, and we take account all this particle, and we go very inner level of study. So this is a relatively very perfect way to study about this system. So I hope you understand studying this system using statistical mechanics this way. Now I'm going to move to another important part, and this part is some basic terminology. Some basic terminology. So this is important actually. So before going to the main topic, you have to know some basic terminology. Energy level, what is energy level, energy state, what is energy state, and what is degeneracy. You have to know about this before learning statistical mechanics. This is the first very important part. So to learn all these things, I will give an example first. Let's suppose this is an atom, and I consider only one cell, and let's suppose there is 2 electrons present in this atom, spin up and spin down. And again I bring another example for better understanding. That there is a building, and there is some room available in its floor. Let's this ground floor, first this is ground floor, first floor, second floor. So there is 3 different room in ground floor and two room in first floor. three room in second floor, and some people is present in ground floor in each room. Uh, in the ground floor, there are three people is present in three different room. In the second floor, two people is present, and third floor, three people is present. So relate this thing, these two things. So here we can consider each floor as energy level. Energy level. Why we can consider each floor is different energy level? Because let's suppose they are each people have same energy because they are in same ground floor. But when one person want to go to first floor, he needs some extra energy. So we can consider this ground floor and first floor as two different energy level. Just relate to this thing, these two things. So in statistical mechanics part, this type of problem will be arise. This type of real problem will arise. But for better understanding, I use this building example here. So your main problem will be like this about an atom, a system of particle, a system of gas, this type of thing. This type of problem will be arise. So now relate. There is this also same energy level. Energy level. You can consider this cell as energy level. So now came to the energy state part. Energy level. I hope you get idea what actually energy level is. Now energy state. Energy state. So what is the energy state? Energy state is the number of room available each energy level. So how many ways a particle can present in each energy level? How many ways? So number of room available in each energy level, or how many ways uh, a particle can present different room. So here three different way a person can stay in first energy level. Here three different way a person can stay in first energy level. So energy state here, building example, energy state is 3. So here energy state will be 3, and but here energy state is 2. Two different way a particle can present its energy level. And next, degeneracy. Degeneracy and energy state relatively same. These two is you can consider as a same term here. So degeneracy also, how many ways a person can present in different energy state. Different energy state. How many ways a particle can present different energy state. Energy state in same energy level. This is the degeneracy actually. In here case degeneracy is 3. And here case degeneracy is 2. Why 2? Because 2 electron can present in same energy level. Same energy level. This energy level is same here. So I hope you understand energy level, energy state, degeneracy. Energy state means number of room available in each energy level. So I hope you understand this three term. This three term actually very important before learning to statistical mechanics. So I hope you understand this all this thing. So I can add now. In tomorrow I will discuss about microstate, 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 macrostate, distinguishable, distinguishable, indistinguishable particle, indistinguishable particle. So tomorrow I'll discuss this, and after that I'll go to the ensemble part. Ensemble part. So it will take around 10 to 20 lecture to 10 to 20 video to complete all this theory part, and after that I'll do calculation. After that so I hope you understand this video, and uh, later I will upload tomorrow. Other part I'll upload